Alright, this video I'm going to actually teach you how to solve the identity part in the trigonometric function for SPM MF. Yeah, because all of this question actually is given by one of my Facebook student, and then the student actually come to ask me about this question, and then he say he tried many times already, and then he still cannot do it. So I decided to take five of the question and actually make a short video to discuss about it. Alright, so let's have a look on the trigonometric function identity question. So before you start to do, I hope actually you can memorize or at least you understand about all these sort of called equation or formula, because you're going to use all of this for the trigonometric identity. So three of these one basically I think will be given in your exam, which is the three formula in this topic: sine square plus cos square equal to 1, tangent square plus 1 equals to secant square, 1 plus cotangent square equals to cosecant square. And another 5 formula here is not the formula, is how you convert cosecant into 1 over sine, how you convert secant into 1 over cos. You must understand all this in order to move on. So since this three formula is given, so I'm not going to say much about that. But then for the cosecant, secant and cotangent, I will say again in how actually you can remember this one. Normally I will see on the third alphabet. You calculate 1, 2, 3. If the third alphabet is S, this one means 1 over sine. You calculate this one, 1, 2, 3, the third alphabet is C, this one is 1 over cos. And then you calculate this one, 1, 2, 3, the third alphabet is T, this is 1 over tangent. So basically, three of these one you know you remember. But then the last one, tangent x equals to sine x over cos x. Yes, this is something you have to remember. Because cotangent is 1 over tangent, you imagine 1 over sine x over cos x equals to cos x over sine x. Means I just flip over the bottom and then multiply. So the formula is here. Okay, so yeah, without wasting lots of your time, so we're going to start on the question. So this is one of the question. Okay, so the question basically asks you to prove your left hand side equal to right hand side. Okay, so or you can use left hand or right hand side equal to left hand side. It doesn't matter. But if I do this kind of question, I will choose the side with more information. So definitely I will choose over here. So I will start with my left hand side. So if I start with my left hand side, so whenever I do this kind of question, and I see the fraction, both fraction plus or minus, so the first thing come into my mind is making them have the same denominator. So in order to make them have the same denominator, this is 1 plus sine delta, right? This is 1 minus sine delta, right? So from this side, I will multiply 1 minus sine delta for both. For this side, I will multiply 1 plus sine delta for both. So, yeah, you will see something like this. So I will do something like, okay, I just show you complete step. Okay, let's say 1 plus sine delta. So I'm going to multiply 1 minus sine delta. I'm going to multiply 1 minus sine delta. Okay, has a bracket for this one also. And then plus 1 over 1 minus sine delta. In order to make them have the same denominator, I will multiply 1 plus sine delta. I will multiply 1 plus sine delta. This is something I will always do if I see the fraction, both fraction, and then question asks me to actually plus them or minus them. Alright, then what I will do is, okay, you will see 1a plus b multiply a minus b. This is same thing, a minus b multiply a plus b. So if you multiply already, you definitely for the denominator you'll get 1 square minus sine square theta. Okay, this is the denominator after you solve already. And then top is just 1 multiply the thing, so it's 1 minus sine delta plus 1 plus sine delta. Alright, then sine delta minus sine delta gone. You left 2 on the top. The bottom 1 minus sine square theta, basically you move the sine square to the other side, you will get cos square. I actually get it from this formula. You just imagine you can move the sine square x to the other side, you get 1 minus sine square x, isn't it? So 1 minus sine square basically is cos square delta. And just now, okay, we know basically this is 2, this one basically is 2 multiply 1 over cos square theta, isn't it? 1 over cos is basically the second. But then it's a square, so you have to add a square for it. So this is 2 second square theta. Then proven. Alright, so this is how you need to solve this kind of question. Alright, it's quite simple. So let me move on to another one. Alright, so for this question, it's quite similar like just now. So basically you have two fractions, and then now the question actually asks you to minus them. So this is 1 minus cos A. I will multiply 1 plus cos A for both. This is 1 plus cos A. I will multiply 1 minus cos A for both in order to make them have the same denominator like just now. So I'm going to do some shortcut here. So bottom I'll get 1 minus cos A multiply with 1 plus cos A. Okay, so you imagine I multiply 1 plus cos A and 1 plus cos A. So the top here, basically I will get 1 plus cos A, the whole thing square. Minus over here, I multiply 1 minus cos A, 1 minus cos A. So the top here, you will get 1 minus cos A square. And then definitely the next step is I will need to expand it. I will choose left hand side now, alright? So the bottom is the same thing. You see 1 minus cos A, 1 plus cos A, you know this is 1 square minus cos square A. A minus B multiply A plus B. This is the very simple formula and somehow it's quite useful here. So let me write here also. It's something like if A square minus B square basically equals to A plus B, A minus B. Alright, so I just want to make sure you can understand this. So when you see 1 plus and 1 minus, and you can actually simplify them become like this. And then over here, because this is square, I will need to expand it. This is two different brackets. When this is two different brackets, you cannot simply multiply the square for 1 and square for cos. It's not like this. You have to open two brackets and then you multiply 1 by 1. So you will get 1 plus 2 cos A plus cos square A minus, this is 1 minus 2 cos A plus cos square A. Okay? Then the negative you have to multiply inside for 3 of it. Okay, so if I multiply negative into 1, I get 1 minus 1. So it's gone. Okay, if 2 cos A minus negative 2 cos A, negative negative become positive. So I will get 4 cos A. Okay, solve it. And then cos square A minus cos square A, I get 0. And then the bottom, 1 minus cos square, you imagine I move the cos square to the other side, you will get sin square A. Alright, then I almost done. Because bottom actually have 2 sine, because sin square A actually means sin A multiply sin A. So what I will do is, I will actually expand them. This is cos A. I take out one of the sin A here because this is sin square A. And then multiply with another sin A. You see, if sin A multiply sin A, you get sin square A. Cos A multiple 1 is cos A. Because why I want to do like this? Because cos A over sin A is equal to cotangent A. And 1 over sin A, 1 over sin, you will get cosec A. Okay, then I will write proven. Okay, it's not really hard, so you just need to understand the concept and then you will find it actually quite simple. Alright, so let me move on because I have 3 more questions. I just don't hope to make this video too long. Okay, so move on to the next one. Okay, so same thing. I will do left hand side because right hand side is only cotangent A. It's so little information for me. So I do left hand side. And then you see 1 is not the fraction. This one is fraction. Same. If not the fraction and fraction, you see minus. Same thing. You have to make them have the same denominator. But before I start to make them have the same denominator, of course you have to understand cosecant A equals 1 over sin A because the third alphabet is S. Alright, so I will do something like this is 1 over sin A minus sin A over 1 plus cos A. You know when you see both of them have the same different denominator, you know you have to multiply 1 plus cos A, 1 plus cos A. The other side here you have to multiply sin A, sin A. So at the end you will get sin A bracket 1 plus cos A here. Okay, that means I already multiply 1, I multiply 1 plus cos A, I will get 1 plus cos A. Sin A, sin A. Sin A, I multiply sin A, I will get sin, it's minus. I will get sin square A. Alright, then I almost done. So this is 1 plus cos A minus, since all is cos and number, so I change my sine square become 1 minus cos square A. And then bottom, I will not expand them. I will leave like this because I know later I can simplify it. Most of the time, I say most of the time, you shouldn't expand the denominator. Always leave in the simplest form. Right? So this one 1 minus 1 is gone. This one cos A minus negative cos A is cos A plus cos square A over sine A. This is 1 plus cos A. And then I see on the top here, both also got cos A. I can factorize out the cos A, isn't it? Then I will get 1 plus cos A. And then 1 plus cos A and 1 plus cos A, I simplify, I left cos A over sine A, which is cotangent A. Okay, this is how I prove this kind of question. Alright, so it's not too hard, so let's continue to last two. Okay, for this kind of question, you don't have any fraction, so yeah, you no need to make them have the same denominator. So before I start to do this kind of question, so I can either choose left hand side or right hand side, but in this case I will choose left hand side because I see this one actually I can easily expand them. So the first thing I will do is I will expand them one by one. Okay, I will expand them one by one. Then 1 multiply 1, 1 multiply negative sine x is negative sine x. Cosec x multiply 1 is plus cosecant x. Cosec x multiple negative is negative cosec x sine x. Alright, so I just expand them. Nothing much I do here. So this is 1 minus sine x. And this one, cosec x, is 1 over sine x. And over here, this is cosec x. Cosec x itself is 1 minus 1 over sine x. Multiply with sine x. So you know, after you simplify already, you left 1. Correct or not? So this is minus 1. Okay, so I have 1 minus 1, it's gone. Then I have this one. Same thing, now this is over 1, this is over sine x. Different denominator, I will multiply sine x for both of these. So I get negative sine square x plus 1 over sine x because I make them have the same denominator. So the next thing I will do, I know 1 minus sine square x equals to cos square x over sine x. And cos square x basically means cos x multiply cos x, isn't it? So cos x over sine x, so I can say this is cos x over sine x, which is we know is cotangent, and this is cos x. So therefore, I will get cotangent x and cos x. And then I will rewrite to make it look like this, so I write cos x, cotangent x. Then I write shown. Or you can write proven or shown. Depend the question asks you to show or prove. Alright, so yeah, this is how I do this kind of question. So before I end this video, I'm going to show you the one last question. Alright, so okay, for this one, you will see something like this. So definitely we will take the left hand side, which is more information. So I take left hand side. For this one, there's no way you can expand, but everything is in this form. So I'm trying to change into everything into sine, cos, and tangent. When I say I'm trying to change everything into sine, cos, tangent, this one I can change into 1 over cos. This one I can change into 1 over sine. But tangent, I'm not going to change into 1 over tangent because I want everything in sine and cos. So cotangent, I will change it into the cos over sine. I will pick this one. Right? So, okay, so this is how I change 1 over cos x multiply 1 over sine x minus cos x over sine x. Alright, then this is minus. Obviously, both of them have different denominator. So I will multiply cos x and cos x here. Alright, so what I will do next is, since I multiply already, both of them will have the same denominator, which is sine x over cos x. This is 1 minus cos square x. Cos x times cos x is cos square x. Alright, so yeah, just some of the students might not understand. Basically, cos square x is same meaning with cos x square. Just in Trigo, they love to write in this form, but they are exactly the same. Alright, so just do not confuse. And 1 minus cos square x is sine square x. And then over sine x over cos x. Since you have two sine here, I can simplify. I left one sine x over cos x, which is tangent x. Then it's proven. Okay, so these identity questions, a lot of the so-called difficult identity questions, all of them will have the fraction. They always come out in the fraction form. And please, you must, when you see the question like this, please, the first thing come into your mind is should always be make them have the same denominator. Alright. Yeah, I think this video is so far is almost 60 minutes. So yes, I'm going to end this video here. If you have any comment, you can post on my YouTube or on my Facebook. Alright, anyways, thanks for watching.